Chapter 17, question 9 says the concentrations of calcium and sulfate ions in a saturated aqueous solution of CaSO4 are both 0.0094. Calculate the solubility product of KSP for CaSO4. So let's set up our overall reaction equation. If I see KSP, I know that CaSO4 is going to be a solid. So that will break up to be calcium 2 plus SO4 2 minus. So if I want to set up my K expression, our KSP is going to be equal to Ca2 plus times SO4 2 minus. So all I have to do is plug in this value here and figure out our solubility product. So our KSP is 2.40 times 10 to the minus 5. Chapter 17, question 10. At certain temperature, that should probably be at a certain temperature, the solubility of strontium arsenate is 0.0570 grams per liter. What is the KSP of the salt at this temperature? So one thing I really want to enforce that the solubility is not the same as the KSP. So the molar solubility is just kind of like how we solve for X. And then KSP is just the overall equilibrium for that solid. We need to figure out what is that X value, and then we could plug everything in. So what I mean by X is if I set up this equation, SR3 ASO4 2, and that's a solid. The SR is going to have a charge of 2 plus, and the ASO4 is going to have a charge of 3 minus. So I have to make sure the numbers out front, make sure the charges are, I guess, balanced. So I need to multiply the ASO4 by 2 and multiply the SR2 plus by 3. So if I was to write out the KSP expression, KSP is equal to SR2 plus 3 times ASO4 3 minus squared. All right. So what numbers do I put here and here? If I was to set up an ice chart, I'm just going to put on the right-hand side because I kind of used at the left-hand side. Anything with a solid is not going to be included, so we're not going to include that in the ice chart. The initial concentrations of SR2 plus and ASO4 3 minus are going to be 0. The change is going to be plus 3x and plus 2x, and at equilibrium it'll be just 3x and 2x. So those are the numbers that we are plugging in here and solving for x, because x equals the molar solubility. Okay. So it will just be KSP is equal to 3x cubed times 2x squared. So let's figure out what x is so we can plug those values in and solve for the overall KSP. So let's go and look at the value they gave us, 0.057 grams per liter, because molar solubility is in moles per liter, and they gave us grams per liter. So we just need to convert grams per liter into moles, and we can finish this equation. So if I have 0.0570 grams of SR3 ASO4 2 per liter, I'm going to multiply by the molecular weight of SR3 ASO4 2 to just be left with moles. So once I figure out the molecular weight, you can just Google it, or you can use your periodic table of elements. I got 540.7. And that's per mole. The reason why I put it on the bottom is because I want those grams to cancel out and be left with just moles over liter. So my X is going to be 1.054 times 10 to the minus 4 moles per liter of SR3. Yeah. All right, so let's plug that into that equation of KSP is equal to 3x cubed. All right, sorry. This is very important. That cube needs to be on the outside because you need to cube both the 3 and the x for this to make sense. Times 2x squared. So that's going to be 3 times 1.054 times 10 to the minus 4 cubed times 2 times 1.054 times 10 to the minus 4 squared. It's really important to make sure your parentheses are put properly for all of your math to make sense. So when I plug everything into my calculator, I get a KSP equal to 1.404 times 10 to the minus 18. Chapter 17, question 11 says at 25 degrees Celsius, only 0.004 moles of the generic salt is soluble in 1 liter of water. Essentially, they just gave us the molar solubility. So X is going to be 0.004 moles over 1 liter. Now, if I set up the ice chart here, I'm not going to have any initial amount of A be solid because it's a solid, but I'll have 0 of our A plus and B minus. My change will be plus X and plus X, and our equilibrium will just be X and X. So I can set up the KSB expression to be concentration of A plus times B minus, which is just going to end up being X squared. So if I know what my X already is, I'm just going to plug that value in. So my KSB for this equation is equal to 1.6 times 10 to the minus 5. Chapter 17, question 12 says when lithium chromate dissolves in water, what ions are produced? Okay, so let's set everything up. So I'm starting with Li2CrO4. And they want you to get that dissolves with water and just think you put it right here. But technically that water is not going to be attaching to any of the lithium and chromium, the chromate, because it is a compound that will ionize completely. So that will turn into lithium 2 plus, that's lithium 1 plus, but there's 2 of them, plus chromate 2 minus. So if it's saying what ions are produced, it's just going to be Li plus, but we're going to have 2 of them, and 1 of the CrO4 2 minus. So don't get confused by the dissolves with water part. Essentially, they want you to set up a KSB expression with this.